Hello students, today we are performing experiment number 13 from the subject Industrial AC Machine. Subject code is 22523. Aim of the experiment is to start a three-phase synchronous motor and run it in a forward and the reverse direction. Means we will first start the motor in the normal direction and we'll see how to reverse the direction of rotation of this motor. The practical significance of this particular experiment is that the synchronous motors, they are normally not self-starting, but initially we have to start them by using some means, and once it is reaching to its synchronous speed value, after that we are connecting the DC supply and we are switching the motor in the synchronous mode. Once you have started it as a synchronous motor, we can use this motor as a synchronous condenser. That is a special property of this motor, that in the industry, this motor is used as a synchronous condenser. Advantage is that normally all the machines in the industry, they are induction type of machines, and the overall power factor of the load is reduced. So to improve that power factor, this synchronous motor is used. This synchronous motor, we can run it for both the leading power factor as well as lagging power factor. So it is useful for maintenance of the power factor of the overall load connected in the industry. Now we'll see what is the minimum theoretical background you should know before starting the experiment. So first point, I already enlightened that synchronous motor is not a self-starting motor. Initially it has to run by some other method, and once it reaches to synchronous speed, after that by carrying out the process of synchronization, the motor runs as a synchronous motor. In this motor, we are using a synchronous motor which is having one damper winding, which is a short-circuited winding. When we give three-phase AC supply to the stator, this damper winding induces an EMF, it carries the current, and the motor starts as an induction motor. So initially the motor starts as an induction motor. So that will be the start mode of the machine. Once the speed is increased and the speed reaches to a speed near about the synchronous speed, at that time the motor switch will be reversed from start mode to run mode. So what is happening that time? That time the DC excitation gets connected to the field winding of synchronous motor, and the field winding poles are created and they get interlocked with the rotating magnetic field flux poles, and that process is known as the process of synchronization, and we say that we have pulled the motor in the synchronism. In the synchronous motor, the rotor is following the rotating magnetic field, and accordingly the machine is also following the magnetic field. So if we want to reverse the direction of rotation of the synchronous motor, similar to three-phase induction motor, we have to change the phase sequence. Means, for example, if initially for forward rotation we are having a phase sequence of RYB, you can change the phase sequence as YRB, and that will complete your second part, that is reversal of the direction of rotation of synchronous motor. So now we'll see the experimental setup. So this machine we will be starting, before starting the motor, actually we are using one auto transformer to give the control input. So to start the connections, you can see first the three supply terminals RYB, they are connected to three input terminals of auto transformer. They are connected to three input terminals of auto transformer, R, then Y, and then B. So these are the three input terminals of the auto transformer. Then three output terminal or variable terminals of auto transformer. Three variable terminals of auto transformer, they are taken to the synchronous starter. In the circuit diagram, synchronous starter is not shown, but we are using a synchronous starter. So from R, Y and B of the auto transformer, we will be connecting to RYB and the neutral. We will be connecting to RYB and the neutral of the starter of the synchronous motor. So that completes the first connection. After that, from the stator terminal R phase, we are connecting one. From R phase, we are connecting one emitter, common terminal, and its new range terminal will go to R phase of the stator of this particular synchronous motor. So that gives to R phase. Y phase and B phase, from the starter to stator, they are directly connected. From Y of the starter to the Y of the stator, and B of the starter to the B of the stator. Then for the field side, F1 of the starter is connected to F1 of the starter is connected to ammeter. Completed the connections from the synchronous motor starter to the stator. In R phase, we have connected ammeter. In Y and B, we have not connected any ammeter. We have just connected the starter to stator. Y terminal, starter to stator, B terminal. In this circuit diagram, we don't show the starter, see the starter, but actually in between the stator and the auto transformer, we are using this particular as a starter. So these starter connections are made available here. You will see that these are R, Y, B and F1 and F2. And these are R, Y, B of the motor, and these are F1 and F2 of the motor. So this much block is not shown in the circuit diagram, but we are using it. Now on the field side, supply positive terminal and supply negative terminal, that we have marked there as F1 and F2. F1 and F2 of the starter. So from F1 of the starter, we are connected to ammeter positive, and negative goes to F1 of the motor field. F1 of the motor field, and F2 of the starter gets directly connected to F2 of the motor field. Double F, it stands for F2. Double F stands for F2, and F stands for F1. So that way we have connected the auto transformer to the starter, and from the starter to the synchronous motor. Now to see that motor is not having any speed variation, we have connected generator as a load. What are the connections of the generator as a load? We connect A1 to F1, A1 to F1, A2 to F2, and then between A1 and A2 we have connected the load. Purpose of connecting the load is that we want to see if the synchronous motor speed is changing, if there is a load variation. So now we'll start the motor and we'll see how to synchronize the motor. Now we want to start the motor, and for that we'll be connecting a 3-phase AC supply input to the auto transformer. So for that we'll make the main switch on. Then after that you have to give the input voltage to the synchronous motor starter terminal. So we are adjusting that voltage to near about 415 volts. Near about 415 volts. So now when you are starting the motor, initially as I have told, it will start as an induction motor, and when it accelerates, after that you have to throw it to run motor. So for that you will see here one switch. This is known as the selector switch, and its purpose is to carry on the process of synchronization. So this is the opposition. When you want to start the motor, we'll rotate this switch to the start position. That means machine will be started as an induction motor. It will accelerate, and within a few seconds it will reach to its synchronous motor. So we'll change the position from start to run. So when we connect it to the run position, actually what happens, this field winding supply from the starter gets connected to the field of the synchronous motor, and that causes interlocking of stator and rotor poles. That is nothing but the synchronization. So after that, even though we increase the load, speed does not change. So we have given the supply. Now we want to start the motor. So for that, we'll throw the switch to start position. We'll throw the switch to start position, and then we'll make the motor on by operating this switch. So motor is started. You can measure the speed, current and voltage. Voltage is, how much is the voltage? 406 volts. Current is, we are using 15 ampere range, so current is 9.2. 9.4 ampere, and speed of the motor is direction of rotation of the, so you will see speed is synchronous speed 1500 rpm. We want to note down the direction of the rotation of the shaft, so for that we will make the motor off and you will see, observe the direction of rotation. Direction is now, it was anti-clockwise rotation. So then in the next part we will see how to change the direction of rotation. So for that we are going to change the phase sequence, means instead of RYB we will make the connections as RBY. We will change the connections for B phase and Y phase. Starter to stator, terminals are reversed. Starter to stator, terminals are reversed. So now phase sequence is RBY. So again we will start the motor. Okay, so supply given is again 409. Supply given is 409, but I am noting this particular reading because now switch position we are going to change. So here to start the motor, again you will see we will keep this switch to start position and we will make the motor on, and then when it is accelerated we will throw it to run position. So how much is the current? It is 10 ampere. Now it is near about 10 ampere, and just we will see the direction of rotation. Clockwise. So this way we have seen how to start the motor as well as how to run the motor in the both directions. Only thing you have to note down here the synchronous speed. So here synchronous speed is calculated as ns is equal to 120 f upon p. Our motor is having p equal to 4. So synchronous speed is 1500 rpm. This is theoretical value, and we have observed that running speed also 1500 rpm. So that is the experiment number 13, in which we have seen how to start and reverse the motor. In the result you have to just write down the direction, then what is the speed of motor, and then write down the question answers. So that will complete this experiment.